In this module, we turn our service wishlist into a real Azure deployment for a regulated KYC wallet platform. You'll see how landing zones, segmented VNets, private connectivity, and high availability patterns come together to form a secure, scalable production foundation. You've already done the hard conceptual work, understanding EUDI 2.0, defining a regulated onboarding journey, mapping compliance to architecture, and selecting your Azure building blocks. Now we shift to how those blocks are actually deployed, segmented, and scaled to safely run real customers in production. For a wallet-based KYC platform, some architectural principles are non-negotiable. Expose as little as possible to the internet, and place strong controls in front of what you must expose. Keep verification, decisioning, and sensitive data processing in tightly isolated zones. Favor private links between services, so data rarely traverses public paths. Then layer on resilience, disaster recovery, monitoring, and repeatable deployments, so the system can adapt to new regulations without constant redesign. A strong landing zone starts with clear separation of concerns. Use management groups to isolate core platform services like identity, connectivity, and security from actual workloads. Then organize subscriptions to mirror how you run the business: production, non-production, shared networking, security tooling, and management. Keep KYC workloads in dedicated regulated subscriptions, separate from general business apps. This makes ownership, billing, risk, and compliance boundaries clean and easier to enforce with policy. Governance in your landing zone is about making good decisions repeatable. First, structure resource groups by lifecycle and ownership, so teams know what they can safely change or delete. Next, apply a consistent naming pattern, like RGKYC prod wave verifier 001, so you can read environment, region, and purpose at a glance. Then tag everything with cost center, data classification, owner, application, environment, and retention. Finally, enforce these conventions with Azure Policy to lock in locations, SKUs, diagnostics, and private connectivity. Environment separation protects regulated onboarding while still allowing fast delivery. Each environment gets its own subscription, or at least strong network and resource boundaries, so mistakes in dev or test can't impact production. Non-production never holds real KYC data, keys, or audit logs. As you move toward production, policies tighten, approvals increase, and privileged access is more restricted. Yet the architecture pattern stays consistent, so what works in pre-prod behaves the same when promoted to production. Segmentation is about creating lanes in your network, each with a clear purpose and risk profile. A shared hub handles connectivity, DNS, and inspection, while spoke VNets host KYC workloads. Within a spoke, subnets separate ingress, application services, private endpoints, data, and management. Network security groups and route tables then define exactly which lanes can talk to each other. This prevents flat networks where verifier, KYC, audit, and admin components can move laterally without controls. Public traffic for onboarding and wallet callbacks should never touch the KYC core directly. Instead, it first reaches application gateway with WAAF, where TLS is terminated, malicious patterns are blocked, and rate limits protect capacity. From there, only validated requests flow into API management, where we enforce policies, authentication, and throttling. All routing targets private endpoints, so application servers, verifiers, and KYC processors remain isolated from the internet. Private endpoints turn Azure PaaS services into internal-only resources. Instead of reaching Key Vault, storage, or SQL over a public endpoint, applications connect to a private IP in their subnet, keeping traffic on the Microsoft backbone. To further isolate sensitive stores, disable public network access wherever possible. Back this with centrally managed private DNS zones and always test routing, firewall rules, and DNS behavior across dev, test, and production. Outbound connections should be treated as a controlled service, not a free-for-all to the internet. All traffic from workload subnets is forced through a centralized firewall or approved appliance, which applies FQDN and IP rules, protocol and port controls, and deep inspection. A NAT gateway or firewall SNAT provides stable public IPs for partner allow lists. Everything is logged, so you can detect misconfigurations, risky data flows, and unexpected external dependencies. OKC platform is only as strong as its connections. Here, think in terms of three zones: enterprise systems, the Azure KYC environment, and external providers. Use ExpressRoute or VPN to keep traffic to core banking, CRM, and fraud systems on private links. Centralize DNS, firewalls, identity integration, and monitoring in a shared hub. Then expose partners only through mediated APIs, with clear, documented trust boundaries for every interface. High availability means designing so that any single failure is an inconvenience, not an outage. Spread compute, databases, storage, and messaging across availability zones when the service supports it. Then decide where multi-region makes sense, based on RTO, RPO, and data residency rules. Mission-critical onboarding, verification, and audit paths usually justify the higher cost. Less critical manual reviews can accept slower recovery with simpler, cheaper redundancy. When onboarding spikes, we don't want verifiers or KYC systems to collapse. So we scale the stateless API and verification layer horizontally and push work into a queue or event stream. That queue absorbs bursts and feeds a pool of KYC, document, and audit workers that can also autoscale. Rate limits and throttling protect fragile downstream services. Because processing is idempotent, retries are safe and never create duplicate profiles or audit records. Environment strategy is about making every environment predictable, isolated, and auditable. Start with infrastructure as code, so dev, test, pre-prod, and prod are created the same way, with consistent network, identity, and security policies. Then isolate configuration. Secrets, endpoints, feature flags, and certificates remain environment-specific. Finally, changes flow through automated validation gates, and production requires explicit approvals, change records, rollback plans, and deployment evidence. You've now turned individual Azure services into a governed landing zone and a secure, segmented network for EUDI Wallet KYC. You designed for isolation, private connectivity, and controlled egress, then layered in availability, scaling, and clear recovery targets. In the next module, we'll extend this foundation with security, privacy, and operational readiness.